So today we have a very interesting geometrical question. The given data is on the screen. You can have a look. So yes, the major part of this diagram was that there were two semicircles in a square. The diameter of the smaller one has been given, that's 24. All you have to do is find the diameter of this bigger one that has been marked as AR in this diagram. So let us see its solution. So first of all, what I have to do is I have to just exclude the variables. If I am considering the side of the square as something, the diameter of the semicircle as something, or the remaining distance, I have to just bring them a relation between all the three. So first of all, let me have the lengths that are very important in this in some kind of variable. So what I can say is I can have the side of the square as a variable. So first of all, taking that as x, that's the side of the square. Now we have that AR, that's the diameter of this biggest semicircle, that what we have to find. And second thing I can have is this length, that's PA. It is like the diameter is touching from one of the diagonal of the square to the side of the square by remaining some distance PA. So it is some kind of importance, so I will just mark it as a distance in variable that's equals to A. So I have taken PA is equals to A, PS, that's the side of the square, as x, so all the four sides are equal, remember, and AR, that's my going to diameter of this bigger semicircle as some variable, let it be equals to B. Now what we have to do is just bring a beautiful relation between x, A and B. Then we can just think further. It's M, N and T are the tangent points. So what I will do is join the center of this bigger semicircle to the tangent point. So as it has been said that yes, W is the center of the biggest semicircle. So from W till T I will just have a line. It's a special line. It's the radius of this bigger semicircle. Now as it has been told that T is a point of tangent, so it will form a 90 degree over there. Yes, 90 degrees is also at the angle P because it is the point and it's the corner of a square. Now what I can observe is that there are three parallel lines because of the perpendiculars. That is this line parallel to this line parallel to this line because of this perpendicular and this perpendicular. If three lines are perpendicular to the same line, that's PA is perpendicular to PQ, TW is also perpendicular to PQ, and QR is also perpendicular to PQ. So yes, these three lines got parallel. Now what I will do is join the diagonal of this square, that's from point P to point R. So having a line, so from point P to point R. Now what is PR? It's the diagonal of the square, and the side of the square has been considered as x. So because of the Pythagoras theorem, I can have that yes, the diagonal, that's PR. So just writing it over here. So diagonal that is equals to PR is going to be square root of 2 times x. Yes, means root 2 times the side of the square. It's the diagonal of a square. That's the length of PR in this particular diagram. Now what I will do is just enlarge the triangle. The triangle I am talking about is P, A and R. I will just draw it a little bit below. Now you can observe I have just taken these two diagrams also. As you can see in this signal diagrams, these two lines are already drawn. So many more lines and angles are required, so they all do not get messy in a single diagram. So I will draw the further explanation in that both diagram. That's why I have kept that both. So just now I am going to enlarge the triangle that is PA and R. So PA, PR and AR. Now marking them. So PAR, and in the middle that's a line that's from point W, and let this point be equals to some variable. All the variables are used. Let this be equals to D. And in this diagram also let us mark that over here. So yes, this point is equals to D. That's the intersection of PR and TW. So that same triangle I have just drawn over here. Now remember that we have taken the length of PA is equals to A. AR is nothing but it's the diagonal of this, sorry, not the diagonal, diameter of this bigger semicircle. So it is having a length in variable that we have taken as B. Yes. Now as I told you that yes, there are three lines were parallel. So PA was parallel to TW. So if two big lines are parallel, if I will just take small segments from that both, so that segments are also going to be parallel. So as in the beginning, in the middle I told you that yes, PA parallel to TW parallel to QR. So if TW is parallel, then DW, which is a line segment on the line segment TW, it's also going to be parallel. So yes, these two parallels. Now W was the center of this bigger semicircle. So if W is the center, so this both are going to be radius and radius, that's half of the diameter. Diameter is B, so it's equals to B by 2, and it is equals to B by 2. Now what you can observe over here, look carefully. Yes, it's nothing but we can have the midpoint here. In a triangle, we are having a parallel line which is bisecting one of this side, so it is going to bisect the other side also. And also if the base is having some length y, so it's going to have a length half the length of the base. it's the midpoint here. So here also I can observe the same criteria. That line, that is DW, is parallel to the base. Yes, it's bisecting one of the side exactly. So it's going to bisect the other side, that is PR, in two equal parts. Now according to the diagram, we got that yes, PR is root 2 times x. So as it has been bisected at point D, so PD would be equals to root 2 times r upon 2, and dr is also going to be root 2 r, not r, sorry, it is going to be x, the variable. So root 2 x upon 2 and square root of 2 times x upon 2. This is the length of PD and dr. And also according to the midpoint theorem, that parallel line is equals to half the length of the base. So base is equals to a, so dw, so it's going to be half the length, that is a by 2. So from here we get that yes, dw is equals to a by 2. It is important. And the second, that is PD is equals to root 2 times x by 2. These two things are important from over here. Now you can have that yes, something is going to happen now. Now just zooming to this diagram. Now concentrate on this triangle, that's PTD. What can you say about this angle? Look carefully. It's just the diagonal, means the diagonal of a square bisects the angle 90 degree as 45. So that angle is going to be 45 degree. PR is the diagonal of this square. This is the side, this is the diagonal. So yes, that angle is going to be 45 degree. So if that angle is 45 degree, this angle is already 90. This is also going to be 45 degree. Let me just enlarge that triangle also over the base. So yes, now over here, that is the triangle over there. Top angle is 90 degree. This we found as 45 degree because of the diagonal of the square. So by angle sum property, this is also 45. The markings are P, T and D. Now P and D was having a length, that is root 2 times x by 2. So root 2 times x by 2. Now we have a right angle triangle. Hypotenuse already given. This both sides are going to be equal. So by Pythagoras theorem, I obtain that yes, the equal sides, that is TD is equals to TP, and it's going to be x by 2. Yes, x by 2. So now what can be used this? Why we have found these two things? Now look carefully the line, that is TW. This complete line, that's TW. I'm just writing it on the side, else I'm writing over here. Look carefully the line, that's TW. So TW, it's divided in two line segments, that is TD plus DW. Yes, the total length TW is equals to TD plus TW. Now what we have done in this two is just found the value of DW and the length of TD, just because to have that two values in this particular equation. So just putting them over there. Now over here, yes. So I was having an equation that yes, TD is equals to, not TD, TW, sorry. Yes, so I was having an equation that TW is equals to TD plus DW. Now what was TW in this original diagram? Look carefully. TW, it's nothing but it's the radius of this bigger semicircle. Radius was already equals to B. Sorry, the diameter was already equals to B. So radius is going to be half the length of diameter, that's B by 2. That is equals to TD. TD is having a value that is x by 2 plus DW, that is having a value of A by 2. So a by 2, so 2 and 2 got cancelled out. So from here I get a very nice equation, or we can say the very nice relation between these three variables, that is v is equals to x plus a. As I told you in the beginning, when we will have a nice relation between the variables, the question can be solved very easily. So what we did is just derive a beautiful relation between the three variables b, x and a. Yes. So now just utilizing this second diagram, so removing these extra things from here. Remember that equation, that b is equals to x plus a. Now in this diagram, just zooming over there. Now we have just taken this much length as a. Remember in this diagram, PA was considered as a. So that much length is a. This complete length, that's from this corner to this corner, is the side of the square. Side of the square is equals to x. So the remaining length, that's from this point to this point, it's going to be longer minus the shorter, so x minus a. Yes, this complete length is already the side of the square, so it's equals to x. This top one, that's the diameter of this semicircle, that was equals to b. Now we have that b is equals to x plus a. Yes, x plus a. And over here it's already equals to 90 degree because it is the corner of the square. So what I just have is a right angle triangle, the side x minus a, x and x plus a. Why we have this right angle triangle? Because as a right angle triangle we have three sides, so we can have the Pythagoras theorem, and there are two variables present. So when two variables are present and we have an equation, one of the variable can be expressed in the terms of other variable. So applying the Pythagoras theorem, so x minus a the whole square plus x square is equals to x plus a the whole square. So from here we get that x square plus a square minus 2 times ax plus x square is equals to x square plus a square plus 2 times ax. So x square a square x square a square got cancelled out. I get that yes, x square is equals to 4 times ax. So from here we get that yes, x is equals to 4 times a. As I told you, we are going to have a single equation having containing both the variables, so we can express one of the variable in other terms. So as x is equals to 4 times a, all the x we can replace with 4 times a. Now x is equals to 4 times a, b is equals to x plus a. So in this, keeping x is equals to 4a gives me that yes, b is equals to 5 times a, and a is already equals to a. Now what you can observe is that in this whole diagram, sorry, a is equals to a. Now what you can observe in this whole diagram, all the variables are excluded except a, all the things we have just expressed in terms of a. Now what data we have just left till now? The data we have just not utilized is that the diameter of this smaller semicircle equals to 24, and that we are going to utilize as the final step. And now what we will do is utilize that data. All the variables are in single terms. If any of the equation we get, we can be able to solve for the value of a. From a we can just solve for the diameter, as the diameter has been expressed in terms of a. So let us do that in this diagram. So yes, now we are just going to utilize the data that yes, the diameter and all the variables in terms of a. So first of all, we have to just mark that yes, diameter is equals to equal, means diameter we have to just mark first of all. So center of this semicircle, and let the color be changed. Red is not looking good. Taking this color, yes, this is the center. From center to the boundary radius, these points are tangent point as per the given data. So 90 degree and 90 degree. The diameter was equals to 24, so its radius is equals to 12 over there, 12 over here, and it's 90 degree because of this square. Now what I am having is a quadrilateral having 3 of its angle equals to 90 degree. So by angle sum property I obtain that yes, this angle is also equals to 90 degree. Now what I am having is a quadrilateral having all the 4 angles equals to 90 degree and adjacent sides is equal, so it's forming a square. It's a normal rule. So over here also it's equals to 12 over this much length is also equals to 12. It's from this point to this point, this point to this point. Yes. Now remember that this length, it's from this point to this point, it's the side of the square. Side of the square is equals to x. X is equals to 4 times a. So this complete length is 4 times a. This much length is equals to 12. So the remaining length, that's from this point to this point, is going to be the longer minus the shorter. So longer is 4 times a. So 4 times a minus 12 is the length from this point to that point. Now over here, this much length was complete, means it was equals to a. This complete length was x is equals to 4 times a. So the remaining, that's from this point to this point, it's going to be longer minus the shorter. So 4a minus a, that's equals to 3a. So from this point to this point, it's 3 times a. And in now that we have that this is equals to 12. So now the remaining, that's from this point to this point, is going to be 3 times a minus 12. So 3 times a minus 12. Now what we have done is just express this, all this smaller line segment in some kind of things. Yes, now remember that this is a straight line, this angle is 90 degrees, so sum of this other two is also going to 90 degree because of the angle sum property. So if this is alpha, this is beta, so alpha plus beta plus 90, write it, alpha plus beta plus 90 equals to 180. So from here we get that yes, alpha plus beta equals to 90. Subtracting beta from the both sides, so alpha is equals to 90 minus beta. Taking tangent on both the sides, so tangent of alpha is equals to tangent of 90 minus beta, that is equals to cot of beta. Now we have the two right angle triangles, that is this, and we can clearly have its value very nicely. So value of tan alpha according to this triangle is opposite, that is 4 times a minus 12 upon the base, that is equals to 12, that is equals to cot beta. So cot beta in this triangle, as these two triangles for 90 degree, these are easy to be found. Cot beta, that is base, so base is 12, and side, that is 3 times a minus 12. So cross multiplication over here, so 12 times a square minus 84 times a is equals to, not equals to, plus 144 is equals to 144. cross multiplication and little simplifications of additions. So 144 gets cancelled out, so 12 times a square is 84 times a cancel the square, and from the table of 12 it goes 12 into 7, that's 84 exactly. So from here we get that yes, a is equals to 7. The question was to find the value of diameter, so we have that b is equals to 5 times a. So b is equals to 5 times 7, that's 35. Yes, b is equals to 35. We can also have the side of the square, that's 4 times a. So 4 times a, that's 4 into 7, that's 28. So yes, we have just found the value of all the three things, that is a, b and x. The only question was to find the diameter, and that's equals to 35. And that's a beautiful answer, that the diameter of this bigger semicircle is going to be 35 centimeter. What we first did is just bring this beautiful equation, that is expressed b in terms of x and a. Then we have just formed a right angle triangle having a single equation by generating Pythagoras theorem to have something relation between two of the variables, that we got that x is equals to 4 times a. So x is equals to 4 times a, then b also got expressed in terms of a. Then finally we utilized the data that the diameter of this smaller semicircle is equals to 24. So that brings us to the solution of this question, that b is equals to 35 centimeter. So this was my method to solve this beautiful question. If you have any other method other than this, you can do comment below, or else you can DM me on my Instagram. Link is in the description. When someone gives a better solution to the same question, and we can show it to our viewers, it's best the knowledge.